Okay, so in lesson 3.3, we are going to be proving lines are parallel. In the last few lessons, or the last lesson, sorry, 3.2, in the problems you were given the fact that the two lines were parallel and then the angles were congruent or supplementary. So, in this lesson, you are trying to figure out what has to be true about certain angles to make the lines parallel. So I'm flipping that statement around using its converse. So corresponding angles would be if J is parallel in this first theorem here, or this first converse, I would have said before, if J is parallel to K, then 2 is congruent to 6. I'm flipping it around saying if 2 is congruent to 6, J is parallel to K. So the corresponding angle converse says corresponding angles must be congruent in order for the lines to be parallel. Alternate interior angles must be congruent for the two lines to be parallel. Alternate exterior angles must be congruent in order for the lines to be parallel. Same side interior angles must be supplementary for the lines to be parallel. And I'm going to fix my mistake down here. I'm going to cross out consecutive, keep that consistency, and I'm going to write this better. I'm going to replace it with same side interior angles to make that more, to make that a little more consistent with what we've talked about before. The only concept that I introduce right now that's new is the transitive property of parallel lines. So, what it says is if two lines are parallel to the same line, they're parallel to each other. So I'm going to put that into some notation right now. What this is saying is that if P is parallel to Q and Q is parallel to R, then P is parallel to R. Okay? If two lines are parallel to the same line, they're parallel to each other. So to show you an example of what I'm talking about, is I'm going to cover example 1 and example 2. So example 1 asks, which lines are parallel if angle 6 is congruent to angle 7? So you're not given that the lines are parallel quite yet. You have to tell me which angles have to be congruent in order for the lines to be parallel. So I'm going to highlight 6 and I'm going to highlight 7 to help me decide. Now, what I'm trying to ask myself is, do 6 and 7 help me compare lines L and M? I'm going to highlight those in red, L and M. Or do they help me determine A and B being parallel? So if you think about it, they would help me determine that L and M are parallel, that L is parallel to M. So we've got to remember what relationship would 6 and 7 have between those two lines. 6 and 7 are in corresponding positions, so 6 and 7 are corresponding angles. Now, for my reason, for my justification, I do not just write corresponding angles. I write this is true because of the corresponding angles converse. That is important, that it is describing the converse of corresponding angles. Because the corresponding angles theorem says if L and M are parallel, 6 and 7 have to be congruent. The converse would say if 6 and 7 are congruent, then L is parallel to M. So that's an important distinction to make when we're talking about different definitions and different theorems. Is it the converse or is it the original statement? So example 2 does something similar. So for example 2, you are given, you're going to be given that 1 is congruent to 2. And if 1 is congruent to 2, I can use that converse of alternate exterior angles, because 1 and 2 are alternate exterior angles, to prove that R and S are parallel. Now another way to explain why they're parallel, we're going to create just a little bit of a proof here. Okay? So we're going to start with what we're given. We're given 1 is congruent to 2. And my reason is going to be that it is given. So those two column proofs we've talked about before. Now the next thing I can say is just based on what I'm given. I don't know anything is parallel yet. I can definitely assume that angle 2 is congruent to angle 3. And I want you to think a minute about the relationship that angles 2 and 3 have. Those are congruent because they are vertical angles. What I want you to understand is that vertical angles have nothing to do with lines being parallel. They're just a relationship between two angles created by intersecting lines. So 2 and 3 are vertical angles. So looking kind of closely at the two statements I have, I can logically make the conclusion that angle 1 is congruent to angle 3. And it's not because R and S are parallel, because I'm trying to prove that. You got to think back to last chapter. If 1 is congruent to 2 and 2 is congruent to 3, then 1 is congruent to 3. So that's an example of that transitive property. If two things are congruent to the same thing, they're congruent to each other. Angle 1 and angle 3 are both congruent to angle 2, so they're congruent to each other. The whole reason I'm doing all of this is to show these two angles are congruent. If these two angles are congruent, I can then make the conclusion that line R is parallel to line S. And that's just like the example we previously did. These two angles are corresponding. So R is parallel to S by that corresponding angles converse. And it's important that you use the term converse and don't just cut it off at corresponding angles, because corresponding angles is the corresponding angles theorem. That assumes that the lines are already parallel. The converse assumes that angles are congruent, so the lines then must be parallel. So we're flipping around that statement as its converse. So I've got one more example. We are not going to cover 3.4 yet. That's for next class. So I am going to just cover example 3, and then you're going to move on to a practice. So in example 3, what is the value of W that makes C parallel to D? In order for C to be parallel to D, the two angles here must be congruent. And the angles relationship would be, or the way I would prove this, my justification, is because these angles are corresponding angles. So I'm going to be using the corresponding angles converse. Okay? To prove lines are parallel, I use the converse. I know each example today used the corresponding angles, but you're going to see other examples where you use same side interior or alternate interior or alternate exterior angles. So these two angles have to be congruent, meaning these two expressions have to be equivalent, meaning 3W, I'll do this better, 3W minus 2 has to be equal to 55. So to solve this equation, I could add 2 to both sides. 3W equals 57. So W really equals 19. And if you're ever unsure of if your solution that you get for W isn't the right solution, substitute it back in. Do 3 times W, or whatever W is, 3 times 19 minus 2, which ends up being 55 because it's 57 minus 2. So you always have a way out of checking your solutions to see that you're doing the problems right. So you should be ready to move on to the practice and then eventually the checkpoint. We will cover 3.4 next time. Make sure you bring the practice class next time in case we need to go over some things just to review and make sure we're all comfortable moving ahead to the next lesson.